Hi, I'm Mehul Shah, the General Manager of AWS Glue and AWS Lake Formation. And today I'll be telling you how you can easily build, secure, and share data lakes on AWS using Lake Formation. Before I get started, let me give you a quick overview of my talk. First, I'm going to motivate why customers are using data lake architectures, and then I'll tell you about Lake Formation itself. Then for the bulk of the talk, I'm going to be talking about the new features, the new capabilities that we've added that make it easy for you to build and manage data lakes on AWS. And then I'll conclude. So if you go back in the past, enterprises used to do decision-making using enterprise data warehouses. It was the central information hub around which all of their decision-making revolved. They would take all of the data that's coming in from their operational databases, their structured relational databases, push it through an ETL process, load that data into a single schema in an enterprise data warehouse, and then analyze that data using SQL reporting tools or business intelligence tools to understand the state of their business and how they could optimize their business. But this particular architecture is increasingly getting out of fashion, and there are three main reasons for this. The first one is that data no longer fits in data warehouses. It's just not cost effective to put all the data that customers manage and want to analyze in a data warehouse. There's more data there than people think. If you look across our customer base, all the customers across in our customer base, you see the amount of data that they're managing is growing about 10x every 5 years. And the data is increasingly becoming more diverse. It's not just structured data. You see customers managing unstructured text and semi-structured logs. For example, application logs, network logs, social networking feeds, mobile events, IoT device streams, and so on and so forth. There's also a lot more people that want to analyze the data, more personas. It's not just executives that are looking at their business, but also product managers, line of business managers, data scientists, data analysts, developers, DevOps specialists, and so on. And they want to analyze the data in a number of new ways. Again, they're not just doing SQL analytics. They're doing machine learning on that data. They're running real-time streaming analytics on that data. And some of them are even doing scientific analyses with that data. And as you make the data more accessible throughout your organization, there's a tension. There's a tension between democratizing access to your data and the new rules and regulations there are in being able to see and use that data, either within your business or within the particular industry. For example, regulations around HIPAA or FedRAMP and SOC compliance. And of course, new privacy regulations that consumers are demanding, like GDPR and CCPA. Now, this is where the cloud comes in. Turns out that we see a lot of our customers taking all of the data out of their data silos and putting it into a central, ubiquitous store, a store like Amazon S3, which is a large object store. It actually allows you to centralize all your data sets because it's so cost effective and extremely reliable. It gives you 11 nines of reliability. And we see customers moving their batch data into S3 as well as their streaming data. Another thing that cloud allows is it allows you to spin up any kind of analytics engine for different purposes on demand as you need, and you can pay as you go. So for example, if you want to do BI, you can use Amazon QuickSight. You can use Amazon Glue or AWS Glue for ETL, Amazon Athena for SQL query processing directly over your S3 data lakes, Amazon EMR for big data processing, and Amazon Redshift for data warehousing. And what customers want is a single locus of control for organizing all this data on S3 and multiplexing that data across these engines as needed in a secure and governed fashion. And this is what a data lake is. It's this new information hub, a centralized, secure repository that enables you to govern, discover, share, and analyze structured and unstructured data at any scale. And we have more data lakes and analytics on AWS than anywhere else. There are tens of thousands of data lakes that run on AWS across a number of industries. Here's just a selection of some of the customers that are on our services. Let's take a look at Lake Formation. Lake Formation is a fully managed service that enables data engineers, data stewards, and data analysts to build clean and secure data lakes in days instead of months. Here's what a solution stack using Lake Formation looks like, a data lake stack looks like. At the bottom, you have your data lake storage on Amazon S3. And then what Lake Formation allows you to do is it gives you a number of features that allow you to ingest and manage the data on S3. It gives you blueprints that are basically templates for getting data out of standard relational databases into your data lake. It gives you new machine learning-based cleaning and normalization transforms that allow you to get your data prepared so that you can run analytics over that data and get good answers and good consistent results. In addition, Lake Formation models your data with a data catalog on S3 as tables inside of databases which have semi-structured rows that have columns and fields inside of them. And in that modeling, what you can do is you can grant permissions to the individual tables as well as your databases, as well as individual columns in those tables to various users in your organization. So it allows you to actually share your data in a very fine-grained way without actually having to copy all of it. And all of the permissions that you specify with Lake Formation are centralized, and they're in a single place so that you can audit them, and you can audit all of the activity within your data lake so you can govern it well. Lake Formation also gives you a comprehensive set of integrated services that integrate with Lake Formation and obey or enforce the permissions that are in there. And today, I'd also like to introduce a new integration, SageMaker, which allows you to build ML models and run ML inference. And now you can drive that model building and inference from the data that's in your data lake through Lake Formation. All right, so in addition, let's talk a little bit about the customers that are using Lake Formation. We have thousands of customers managing petabytes of data on Lake Formation. Here's just some selection of the customers that are there, and you can see they span the gamut from insurance companies to banking companies to media companies to healthcare companies. For example, OneFootball is a popular fantasy league and digital media platform for over 70 million football or soccer fans. They're using blueprints to ingest live scores and game statistics and football news from over 200 different leagues into a central data lake. It eliminates the need for doing ETL in their platform. Curvo is a healthcare spending management platform. They're using Lake Formation's approximate matching machine learning transforms for deduplicating and integrating medical product order data from thousands of different hospitals. Using these transforms, they reduce the time to process their data sets from over a week to less than a few hours, and they improve the accuracy to nearly 100%. Free is a leader in cloud-based accounting and HR, based out of Japan. They find it easier to manage all of their Lake Formation permissions, all of their data lake permissions with Lake Formation instead of modifying and managing S3 policies. FanDuel is an online fantasy sports and bookmaker with over 6 million registered users. And Macromill is a marketing research and digital marketing solutions firm. And they're using Lake Formations to actually hide sensitive columns that are in their data lake tables to restrict information like personally identifiable information, PII data. All right, let's talk about some of the recent innovations in Lake Formation. Since we launched last year, we've added 20 plus new major features and a number of new regions. But even still, what you're telling us is that managing S3 data lakes is still hard. You're doing new things with your data lakes. One of the things that you want us to support are streaming updates and deletes in your data lakes, for example, for database replication and for supporting privacy regulations. And today, that's still very hard. You've also asked us to do even finer grain sharing using row-level security. And then finally, you've asked us, can you help us please manage all the various files and tables that we have on our S3 data lakes, because they're actually organized in a suboptimal way, making analytics go slow. So I am proud to announce today a preview of 3 brand new features: transactions, row-level security, and acceleration in AWS Lake Formation. These features help you accelerate and govern accesses to your Amazon S3 data lakes. We're actually delivering these features through brand new APIs in Lake Formation. These are update and access APIs. These APIs support open standards and are public. So in addition to being able to use Lake Formation through the integrated services, you can now build your own applications that work directly over your data lake. These APIs support atomic, consistent, isolated, and durable or ACID transactions so that you can update your data lakes in a concurrent and consistent way. They enforce or apply row-level filtering for fine-grained security. And they encapsulate a number of optimizations so you can run analytics on S3 extremely fast. So I'm going to walk through each one of these features and discuss them in depth. The first one is transactions. Why would anyone want to run transactions on your data lakes? Well, it turns out we found our customers building complex ETL pipelines to update the data in their data lakes. And to make sure that these updates are consistent, it takes actually some time for the updates to settle. And so that means that the data that you want to analyze is typically not fresh. It's delayed. And these pipelines are expensive, brittle, and error-prone to maintain. We also see our customers wanting to delete individual rows in their S3 objects in their data lakes to comply with privacy regulations like GDPR and CCPA. And doing those deletes, because S3 is an immutable store, these objects need to be completely rewritten. And so it ends up in creating write amplification in your S3 data lakes. With transactions, you can easily build applications on Amazon S3 data lakes because they allow for concurrent inserts, updates, and deletes that pretty much appear immediately as soon as they're done. To use transactions, we introduce a new type of table on S3 called governed tables. And it's governed tables that support transactional updates in your data lake. They support ACID transactions. What a transaction is a sequence of operations that appears or happens atomically. And those operations appear to get a sort of an isolated view of your data lake when they run. You can have multiple operations in there. These transactions can operate over multiple tables, and they can be run concurrently, and they won't actually clobber each other from different users and from different engines. The cool thing about governed tables is that the data that governed tables manage actually are stored in your S3 buckets, in the customer's S3 buckets. So you retain control over your data. The data is stored in open file formats like Parquet, CSV, and JSON. And we make it super easy and fast to import and export data from popular table formats like Apache Hudi, Delta Lake, and Apache Iceberg. And finally, since governed tables actually track all of the possible updates, you can access a previous version of your data lake at any earlier point in time. So we support time travel. Let's see how all this works. To understand how governed tables work under the hood, let's take a look at how traditional S3 data lake tables look like. They're really just Apache Hive style tables. What you do is you take all the rows in your table, put them in various files or S3 objects, and those files are organized under directories, if you will. And the metadata for these files are actually maintained by S3 itself. Now, a governed table is just kind of like a regular role table, except the metadata is now managed by Lake Formation. A manifest basically comprises all the files that are in that table. Okay, and all the actual all of the actual files still remain in Amazon S3. The manifest actually just comprises all the metadata for those files. And this is why import and export is easy, because it's really just a metadata operation. Govern tables also support two different types of updates APIs. The first type of update APIs are transactional manifest-based APIs. And what they allow you to do is add or remove files to your table transactionally. So in this case, I've added 3 files, the orange files, to my table, and the manifest is now pointing those to those 3 files, and you've created a new version of the manifest. And you can actually run these transactions concurrently, and we'll order them for you. In this case, the blue transaction added 2 files, and it came after the orange transaction. And the data structures that maintain these manifests are pretty efficient. And so what we allow you to do is very quickly go to a previous version of the table in an instant. We also provide row-based transactional APIs that allow you to insert, update, and delete rows within the table. The way this works is, here's your govern table with its base data in S3. And any changes that we have to that table will actually store in these Delta file that contains those edits. And then when you try to retrieve those records, the Lake Formation APIs will actually resolve all those changes and give you a consistent view of your table. Let's see how all this works with an example. Imagine you have an e-commerce retailer that's maintaining a products table. And what we're going to do is we're going to run 2 different transactions side by side and show that their effects are isolated from one another. We're going to have those transactions running in 2 separate Jupyter notebooks, and those Jupyter notebooks are attached to a Spark cluster, which is being managed by AWS Glue. And so it's loaded with Glue ETL libraries. And one of those notebooks is going to be doing reads and updates, and the other notebook is just basically going to be doing reads, simulating analytics. All right, so let's get started. Let's just set up the notebooks with the database and the table that we're going to access. And then we're going to start a transaction. And now anytime you work within a transaction, you're going to get an isolated view of your data lake. On the left-hand side, notebook number 1 is reading the table of products, and notebook number 2 is also reading the table of products. And you'll see that they see exactly the same set of rows. Now, notebook number 2 is going to continue to read, while notebook number 1 is going to actually add 2 new rows to your products table. And then when you read and print the products table again, and the transactions are still running, the effects of adding those 2 rows from notebook 1 are only seen by notebook 1. It gets basically its own little copy or its own little view of its data lake. Now, these effects have not been reflected into the data lake yet, and so notebook number 2 still sees the original data. It's not actually visible outside of that transaction yet. And now let's go commit the transaction. What that's going to do is actually install the results into the data lake. And now if you try to read the data again with a new transaction, both notebooks are going to be able to see the new data that was added. Pretty simple, right? Well, the cool thing about transactions is it doesn't matter what happens, whether there are 100, 1,000, lots and lots of transactions can be running simultaneously, and each transaction will still get its own consistent view of the data lake. In addition, any failures or any cancellations that happen because of various application scenarios, you still maintain consistency within your data lake. So it's a very general mechanism, and it makes it much easier to build your applications. Huddle is a performance analysis company. They're working with coaches and athletes to stay ahead of competition. And what they are excited about is that these transactions in Lake Formation are going to help them simplify their ETL pipelines and make sure that the quality of the data and the trustworthiness of the data in their data lake is improved. All right, now let's talk about row-level security. Why do we need even more finer-grained security? Well, often you have really, really large tables, these fact tables in your organization that you want to share across a number of users and groups and departments. For example, in healthcare, you might have patient records, and admins should be able to see all of those records, while doctors and nurses should only be able to see the records for their particular patients. Or if you're a retailer, you might have multiple stores and multiple managers of those stores who are allowed to see their respective stores' records, but regional managers are allowed to see the entire records. Now today, if you want to allow these kinds of accesses, again, you have to make copies of your data and set up ETL pipelines to maintain those copies. And those multiple redacted data sets are expensive and cumbersome. And Lake Formation row-level security basically makes this all very easy. You can now provide security policies at the table, column, and at the row level. And these security policies are uniformly enforced, so you can build and maintain granular compliance policies across your organization. The way this works is you basically specify row filter expressions for the users that want to access these tables, and that'll filter out only the rows that you specify that they're supposed to access. The way you do these expressions is by providing a where clause in a SQL statement. The variant of SQL that we're running is particle, which is a superset of SQL that was designed for semi-structured data. The cool thing is that you can enforce these row-level permissions not just for governed tables, but it also works for all of the other managed tables that and open formats that we support. For example, Redshift data shares, Apache Hive, Apache Iceberg, Apache Hoodie, and Delta Lake. And because all of this is happening through a single place, which is Lake Formation, it's easy to audit the permissions across your organization and audit all the accesses that are happening to your data lake across your organization. Again, let's see how this works. Let's take an example of row-level security. Imagine you have CloudTrail data. CloudTrail basically records all the events in your account in AWS when you're accessing various services within AWS. And it records those API accesses basically in a single place in S3 in a variety of files. This is basically a CloudTrail table, if you will. Now imagine you have 3 different types of admins who are only supposed to be able to access certain events. For example, compute admins are allowed to access events that are coming from EC2. Data admins are allowed to access events that are related to Lake Formation, and storage admins are allowed to access events that are related to Amazon S3. Well, it's really easy to specify row-level permissions, grant them, for example, to these different user personas through the console or the Lake Formation APIs. You simply specify the principal. In this case, we're specifying the compute admin. You specify the resources. In this case, it's the CloudTrail table that we're talking about. And then you specify a row-level filter. It's just an equality here that this particular column event source has to be equal to EC2. And so that actually brings out the EC2 events. For the storage admin, we're only going to be allowing the S3 events. And then for the data admin, we're going to be only allowing the Lake Formation events. Now, when those admins go into the console in Athena, for example, and start querying that data in your data lake, they're going to only see the events that they have access to. So the EC2 related rows for the compute admin. This is just doing a select star from that table. So storage admin will see the S3 events, and the data admin will see the Lake Formation events. All right, so that was row-level filtering. Now let's talk about acceleration. Why do we need even faster access to S3 than we already have? Well, it turns out when we looked across our customer base, we found that all of the engines and all of the analytics that they're doing in their data lakes, they're often retrieving more data than they need. In fact, for most of these queries, more than 80% of the rows that are retrieved from S3 are filtered away. We also found out that when you look across our customer base, they're managing lots and lots of small files in S3. These come about because they're storing, for example, streaming data, or there are a lot of granular updates to those files, and so there's lots of little deltas that they keep around. And when you have this and you're running queries, it turns out that retrieving those small files, the I/O cost of just doing those requests actually dominates query performance. It's not actually the cost for actually processing the files themselves. And so we added 2 new acceleration capabilities within Lake Formation, pushdowns and a storage optimizer. So we already have these read APIs that are enforcing row-level security, and they're basically running filters over your data. So in addition, you can push down additional filters that you need when you're running your analytics. And you can also push down other aggregations, for example, sums and averages and variances. And in addition to computing, the rows that you're allowed to see because of the row level security primitives that we're giving you, we also apply the additional filters and the aggregations, and this reduces the amount of data that comes back. We also have a storage optimizer for governed tables that works in the background, and it automatically compacts small files into larger ones and automatically merges deltas into the larger files as well. Let's see how this works. Remember the CloudTrail data? Well, we stored it in S3 through a streaming system. And on the left-hand side, you see that through the streaming system, you end up getting a bunch of really tiny files, 3K files. And then we also stored it in governed tables through a streaming system, but governed tables are being constantly compacted. And so you see 40 megabyte files. What's the difference? Well, when you do a query over the regular old table, query takes about 26 seconds for this data. And it's about 10 times faster over governed tables because you're actually processing data rather than making fetches to S3. Now, let's take a look at how time travel works. Here's an example where we're looking at the CloudTrail data, but on the left-hand side, we're just running a simple query as of today, as of now. And on the right-hand side, what we added is a little predicate there that says, give me the results as of a previous point in time. And that basically initiates time travel. It allows you to take a look at the version of the data lake as of that point in time and run the query against that version. In this case, it was November 25th. Happens pretty quickly. It's almost instantaneously. Finally, I want to talk about one more thing that we've added. So if you wanted to share data across accounts using Lake Formation, you used to either have to duplicate your data, which meant, again, more copies, ETL pipelines to update these things, and then managing those pipelines is cumbersome. Or you would expose those data lakes through S3 policies and IAM policies. And unfortunately, if you did that, you lost all of the fine-grained permissioning that Lake Formation provided you, and you'd run into various policy size limits. So a few months ago, what we introduced was AWS Lake Formation cross-account sharing. The way this works is, imagine you have a producer account on the left-hand side, which has a data lake that it wants to share with the consumer account. And in this data lake, you have a sales database with an opportunities table. Well, just like granting permissions to individual users, you can grant permissions to another account. And what Lake Formation will do is it'll share those resources to the other account. Those shared resources are then now available to be linked into the local data catalog that account has. And these are soft links. And then the data lake admin can delegate access to those links to individual users in that account. And then they can operate over that data, and that's been exported and shared as if it was within that account without ever having to copy data or move data. And you get to maintain all of the fine-grained permissions that have been shared. With this, it actually opens up a whole new set of possibilities because you can now share subsets of petabytes of data across accounts. We see a number of different topologies. We see, for example, a centralized hub and spoke topology, where there's a centralized data lake that you're sharing with a bunch of consumer accounts. We also see a producer-consumer relationship between organizations and between companies, where vendors are sharing with suppliers and aggregators are sharing with distributors. And we also see companies building peer-to-peer relationships between data lakes to build data meshes. It really opens up a new possibility in sharing. GoDaddy is a website hosting company that's used by more than 20 million customers worldwide. And D2C is a digital advertising company and marketing company from Japan. Both of them are using Lake Formation's cross-account access to simplify their data sharing in their companies. And GoDaddy's mechanism or pattern is a hub and spoke architecture. All right, so let's wrap up. Last year we launched Lake Formation. It was really designed to help you build clean and secure data lakes on AWS. There are a number of integrated services that you could use with Lake Formation. But since then, we've added a whole bunch of new APIs that support transactions for concurrent and consistent updates, row-level security for unified governance across your data organization, and a number of optimizations that accelerate analytics on your S3 data lakes. And these new capabilities allow you to retain control over your data, support open standards so there's no lock-in, and efficiently share petabytes of data across organizations and across companies. And so we envision a brand new ecosystem of third-party applications, applications that you can roll on your own, and Lake Formation is now more than just for building and managing data lakes, but it's becoming the foundation for analytics on data lakes on AWS. Lake Formation is available in 20 different regions. There are a number of integrated services that Lake Formation supports, and new ones that are coming every day. And we encourage you to sign up for our new preview. Thank you so much. If you're interested, please complete the session survey at the end of the talk.